Section 5.6 exponential equations. So we're going to solve exponential and logarithmic equations using a variety of methods. Now for these equations, remember that we have some properties that we know that we're going to look at. So because exponential and logarithmic functions are one-to-one, the following statements are true. If u equals v, then if you have something with the same base, such as right here for this first one, you have b to the u equals v to u, that's going to be true if u equals v for the exponent. So when you have the same base and you're solving for an exponent, so you can just set them equal to each other to solve. Then for the next one, if you have the log base u b of u and the log base b of v, those are going to be equal to each other as long as u is equal to v. And then for this next property, it's just the converse of the first one that we said, and so is this one right here. Now, when you're solving an exponential equation, that means you have a variable as an exponent. So you always first want to try to get the same base if you possibly can. If you can't get the same base, then we'll solve it a different way. So if you look at this first question, A, we can make 9 into base 3. So since we can make that a similar base, we can solve this quite easily. So this would be 3 to the second power all to the x, because 3 squared is 9, equals 3 to the x minus 1. Now for this, since I have the same base, I can simplify this. This would be 3 to the 2x equals 3 to the x minus 1. By that first property that we said, that means that my exponents have to be equal to each other. So to solve this problem, I can take my exponents, which would be 2x equals x minus 1, and then just go ahead and solve for x. So if you solve for x here by subtracting x to the other side, you get x is equal to negative 1. And then if you plug this back in for x, you would see that it checks out. Now, remember when we're solving exponential equations, you can put anything in for your x values, so your domain's all real numbers, which is not true for logarithmic equations that we'll solve next. So if you look at b here, notice that you have 6 to the x power equals 3. Now, this is an exponential form. Remember we said if it's an exponential form to solve, you want to put it into logarithmic form. So since we can't get the same basis here, that's what we're going to use in order to solve. So this would be the log of base 6 of, in this case, 3 is equal to x. Now, because we learned the change of base form, that means that we can use that in order to solve. So x would be equal to the log of 3 divided by the log of 6. And then I want to see this for your answer, and then I also want to see the decimal form for your answer. So you would have to plug this into your calculator, and I recommend that you guys, as we're going through these problems, really plug them into your calculator to make sure that you can get them, because students make a lot of mistakes just plugging it in correctly. So when you plug it into your calculator, you should end up with x is equal to 0.6131, and so that would be the decimal of this. So let's go to C here. For C, if I look at this problem, again, I cannot make 4 into base 5 ever. So since I can never make 4 into base 5, that means, again, I'm going to have to use logarithms in order to help me solve this. Now, because I have exponents on both sides of my equation, which is unlike this problem that I just did for B, we only have the one exponent, I'm going to have to take the log of both sides, or you can also use the natural log. It won't change the equation. You'll get the same answer in the end. So I'm going to take the log of both sides. So this is going to become the log of 4 to the 2x minus 1 equals the log of 5 to the 1 minus x. And we're allowed to do that because if we take the log of both sides, it doesn't change my equation at all. So then I can go ahead and bring this down in front by my power property. So when I do that, I get 2x minus 1 times the log of 4 equals, this would be the 1 minus x times the log of 5. Notice that I put those exponents in parentheses because 2x minus 1 is being multiplied all by the log of 4, and 1 minus x is being multiplied by the log of 5. If you don't put those parentheses there, then you might accidentally think you have 1 minus x times the log of 5 as your problem, and then that would be completely different. So now if we look at this, I need to solve for x. But notice I have x's on both sides of my equation. So since I have x's on both sides of my equation, that means I'm going to want to distribute that log that I have. So I'm going to distribute this log to here, and I'm going to distribute this and this. So when I do that, I get 2x times the log of 4 minus the log of 4 equals the log of 5 minus x times the log of 5. And then I'm not done. So now notice I have an x over here that I'm trying to solve for and an x over here. That means I'm going to want to try to get those on both sides. And so anything that doesn't have a log or x in it, I'm going to put on one side of the equation. Anything that does, I put on the other. So I'm going to go down here to get more room. So when I do this, I get 2x log 4. I'm going to, in this case, take this and add x log 5 to this side over here. So this would be plus x log 5. And then I want to get the log 4 to the other side. So in order to get this to the other side, I have to add it. So when I add that, that gives me log of 5. Oops, so log of 5. Okay, so log of 5, I don't know why this is being slow, plus the log of 4. Now, if we go back over here to our equation, I have an x in both my terms. So in order to get it by itself, since these are not like terms, I cannot combine them together because in order to be like terms, you have to have the same base and the same number that you're taking the log of. We're taking the log of 4 and 5, and that's not the same, so we can't combine it. So I have to factor out that x, which would then give me 2 times the log of 4 plus the log of 5 equals the log of 5 plus the log of 4. Now I'm not done because I want to solve for x. So in order to solve for x, I'm going to have to divide by 2 log 4 plus log 5 because that's being multiplied by x. So when I divide both sides by this term, I get x is equal to the log of 5 plus the log of 4 over 2 times the log of 4 plus the log of 5. So I want to see this part for your answer, and then you're going to have to find or approximate the decimal answer by plugging into your calculator. Now, I suggest that you plug this into your calculator right now to see if you can get the same decimal answer, because students quite often can't plug this in correctly. Make sure you have parentheses around what's in your numerator and what's in your denominator, and also make sure that you close the parentheses when you're taking the log of something. So for this, the x would be equal to, in decimal form, 0.6836. So make sure that you can get that. If you can't, keep plugging it in until you do. For this, and look at this equation here, we can really simplify this more, but it's not necessary to. Like log of 5 plus log of 4, since you have 2 logs being added with the same base, you can multiply the 5 times the 4 and get the log of 20, and then you can simplify the denominator as well, but it's not necessary, so we're just going to leave this as our answer and also this. So let's go ahead, and if you look at D, we're going to save that one for class. So I'm going to move this stuff right here so that I have room to do the next problem. I'm going to move that up here. I'm going to make it smaller. Oops. So I'm just going to move that over here. That didn't really work out very well. So I'm just going to erase that. So you guys should have it written down. I'll get that out of my way so I can do this next problem. All right, so for the next example, it says If $8,000 is to be invested at 6% per year, compounded monthly, and how many years will the investment be worth 22,520? So this is using those formulas that we used before. We are compounding something monthly. So since we're compounding something monthly, we're using the formula A equals P times 1 plus your rate divided by the number of times you compound it, and then your time times the number of times you're compounding it. So in this case, it says we want to figure out and how many years our investment is going to be worth that amount. So we have our amount A, 22,520, is equal to our principal or starting amount, which is 8,000. And we have then 1 plus our rate, which is 6%, so 0.06 compounded monthly. And we're trying to figure out the number of years, so x times 12, or 12x. Now before, when we solved these, we plugged them into our calculator and found the intersection. Now that we've been solving logarithmic equations, we can go ahead and solve this using our equations that we learned. So that means I'm going to want to go ahead and simplify this. So I have 22,520 equals 8,000 times, this is 1 plus 0.005 to the 12x power. Now, in order to solve this, I'm going to have to first divide by 8,000 on both sides. When I divide both sides by 8,000, I get 2.815. And again, I'm solving for x. So notice that we have just the exponential part equals a number. So if I want to solve this, I can solve it by putting it in logarithmic form, or I can take the log of both sides to solve. So I'm going to go ahead and do both. So if I put this in logarithmic form, I would get the log, and the base would be 1.005 to the 2.815 is equal to 12x. And then in order to solve this, I would have to put the left side of this equation in using the change of base formula. So that would be the log of 2.815 divided by the log of 1.005, and then I can do it in my calculator since it would be base 10 equals 12x. So I would do all of this in my calculator. After I do all of this in my calculator, then I'm going to divide both sides by 12. And you want to try not to round your answer to the very end. So when you do all of that divided by 12, you end up with x, your time, being equal to 17.29 years. You could also check that by plugging it into your calculator and seeing if you get the intersection. Right here, I could have solved that a different way, or actually I should have said right here I could solve that a different way. So for this one I have 2.815 equals 1.005 to the 12x. Since they're not the same bases, I can just go ahead and take the log of both sides because that doesn't change your equation. If I solve the problem this way, that's okay. I would want to take this down first from your power, so then you would get the log of 2.815 equals 12x times the log of 1.005. And then notice that I have all of this being multiplied by the x, so that means I'm going to divide by that. So I have the log of 2.815 divided by the log of 1.005. And then notice that's the same thing we had over here. All I need to do last is divide by 12. So then I would take this whole answer and divide it by 12, and I would get the same solution. So those are two different ways of solving the same problem. All right, so let's go to the next one. For the next example, it says the population of a certain species of rabbit increases exponentially according to the function that's given, where P is the initial population and R is the continuous growth rate. At the beginning of a 12-month study, there were 50 rabbits, and at the end of the study, there were 164 rabbits. Write a function for this population. So if we want to write a function for this population, we know we're using PE to the RT power because that's what it told me in the problem. I just need to plug in find my initial amount and my rate. So in this case, we were not given that. We were given that they initially started off with 50 rabbits, so we do know that. So I'm using A equals PE to the RT power. That's a power. So for this, I know I started off with 50, and I know that's going to be times E because that's always in my equation. And for this one, the only other thing it said is that at the beginning of a 12-month study, there were 50 rabbits. By the end of the study, there's 164. So I know that that's my amount. And my rate, we do not know. We have to solve for that. But I do know that time t, which is in months, is 12. So then I can go ahead and solve this equation. So I need to solve this equation for R. And for this equation, because it's talking about a 12-month study, normally we put things in time in years. You can do that here, which will be easy to do, which we'll talk about later with our answer. But for right now, since it's the months, we can leave that for our time in months right now. So when I solve this equation, I would divide by 50. And since this is base E, I'm going to use natural log and rewrite this. So I can take the natural log of both sides, or I can write this in natural log form, just like I did in the last equation. So this would be the natural log base E, which we don't need to write base E, of 3.28 equals my exponent. So I'm doing the natural log of 3.28. I'm going to divide both sides by 12. That's going to give me my R value, so this would be gone. So R in this case is going to be equal to 0.099, which is 9.9%. So that's my R value. So I'm going to use 0.099 in my equation. So the function for this population would be S of t is equal to 50 e to the 0.099 times t. So that's my equation. Then the next part says, when will the population reach 1,000? So that's the population, so we need to figure out the time. So that means I'm plugging in 1,000 into this equation for the population equals 50 e to the 0.099 t. So I'm solving for time. Now, first things first, I would divide by 50, and you get 20. So when I divide by 50 on both sides, I get 20 equals e to the 0.099 t. Now I have to solve this equation, and I'm going to solve it differently than I solved the first one. So you can solve it by putting this in natural logarithmic form, or you can solve it by taking the natural log of both sides. Again, both will yield the same answer. So if I do the natural log of 20 equals the natural log of e to the 0.099 t, then for this one, I would want to bring this down right here because we don't want the exponent. So this would be the natural log of 20 equals 0.099 t times the natural log of e. Remember that the natural log of e is really equal to 1. So that's really like I'm solving natural log of 20 equals 0.099 t. So then the last step would be divide both sides by 0.099. And of course, you want to practice plugging this into your calculator. So when you do that, you end up with t is equal to 30.26 in months. Remember, we were doing. And if I want to put this into years, I know that there's 12 months in a year. So all I would have to do is divide that. And you end up with about 2.5. So if I wanted the years, t would be equal to about 2.5 years. All right, so, and again, for that equation, I could have also solved it by putting it in natural log form, which I'll do down here really quickly. So I could have done the natural log of base e of, in this case, 20 equals your exponent 0.099t, and notice that gives me the same thing that I did up here. So either way will work for those equations. Sometimes one way is faster than the other, and it just depends on what you kind of prefer. So for the next equation, it says the population of a certain bacteria culture at time t hours is given by the function f. So how long will it take for the bacteria, the population, to reach 8,000? So that means that I'm plugging 8,000 into my equation. And I'm actually going to do this on another piece of paper because that's going to take too much room for me to write. So we have 8,000 equals 20,000 divided by 1 plus 20e to the negative t over 3 power. So if you want to solve a problem like this, if you have a fraction equals a number, the best way to do that, especially since our exponential part is in our denominator, you're going to want to put 8,000 over 1 and cross multiply. So here we get 20,000 equals 8,000 times 1 plus 20 e to the negative t over 3 power. So now when I go ahead and solve this, I would divide both sides by 8,000 first. So when I divide by 8,000, I get 2.5 equals 1 plus 20 e to the negative t over 3. Now, I can't put this in logarithmic to solve for my exponent yet because I don't have just the exponential part by itself. That's the first thing that I need to do. That means that I need to, in this case, first I want to get rid of that 1 by subtracting it from both sides. So when I do that, I get subtract 1. I get 1.5 equals 20 times e to the negative t over 3 power. And then from here, I would probably take that 1.5 and divide on both sides by 20. And so divide this by 20. And so if you do that, you get 3 over 40. I'm going to leave it as a fraction, equals e to the negative t over 3. Now that we have just the exponential part by itself, to solve for the exponential, you do the inverse, and you can now use natural logarithms in order to solve. So you can take the natural log of both sides, or you can just write this in natural log form. So natural log base e would be written already of your answer, 3 over 40, gives you your exponent, which is negative t over 3. So for this problem, I need to go ahead and solve for t by multiplying both sides by negative 3. So this would be negative 3 times the natural log of 3 divided by 40 gives me my t value. So plugging this correctly into your calculator would yield t being equal to 7.77 hours. So again, make sure that when you're doing these problems, you practice plugging them in so that we can see that you get the same answer. And if you don't, I would practice plugging it in again and see what, maybe you put parentheses in the incorrect place. All right, so we just did that problem. Now the next ones we're going to do are logarithmic equations. Now these are different than the exponential equations. For the exponential equations, if I go back here, remember to solve, you try to get the same base. If you can't get the same base, then you have to write it in log form in order to solve. Now when we're doing logarithmic equations, if you can't get the same base and to solve, then you're going to have to put it in exponential form to solve for the exponent. So in this case, don't forget when you're solving natural log or log forms, you have to be careful to make sure your answer fits in the domain. So always check the domain. So anytime you're solving natural log or log, remember to check the domain because it has to be greater than 0. for this, when we look at this first equation here, if I want to solve this natural log equation, the first thing I have to do is I need to use those properties and combine it into one natural log. So if you have two natural logs being added, to combine them, you multiply what's on the inside. So this would be the natural log of 4x minus 1 times x plus 2. And that's all equal to 2 times the natural log of x. So then the next thing that I would do is I would bring this up as a power. So you get the natural log of 4x minus 1 times x plus 2 equals the natural log of x squared. So remember, by those properties that we said in the beginning, if we have the log base b of u equals log base b of v, then u has to equal v. So we can use that property in order to help us solve this equation here. So since I have natural log here and here, therefore this and x squared have to be equal to each other. So I would do 4x minus 1 times x plus 2 has to be equal to x squared. So of course, in order to solve this, I'm going to have to FOIL or box out the 4x minus 1 times x plus 2. And when we do that, we get 4x squared plus 7x minus 2 equals x squared. Now, since this is a quadratic equation, we've learned how to solve these for x. There's many different ways you can solve. You can use a quadratic formula, you can factor. So I'm going to have to first set it equal to 0 by subtracting x squared from both sides. When you subtract the x squared, you get 3x squared plus 7x minus 2 equals 0. Now, in order to solve this, I'm going to have to use a quadratic formula. And when you do the quadratic formula, go all the way through it, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which I'm not going to go through. You get negative 7 plus or minus the square root of 73, 73 all over 6. Now, remember, we can't say that both of those are answers because we have to check to make sure everything's within our domain. Right here for this first part, if we set 4x minus 1 has to be greater than 0, you would get x has to be greater than 1/4. Here, x has to be greater than negative 2. And here, x has to be greater than 0. So look for the one that's the largest, and that's the one that you're going to go by. So x has to be greater than 1/4 in this case. Now, if we do our equations, that means we're going to have to find the decimal of each of these. So we're going to have to do negative 7 plus root 73 divided by 6 and negative 7 minus root 73 divided by 6 and check the decimal form of each of these. So I'm going to plug that into my calculator and you guys can do the same. So for this first one, I get 0.2573 something, keeps going. And then for the next one, I get negative 2.5907. So if you look at that second equation, that does not fit in the domain. The top one does, though, because 0.25 is bigger than 1/4. So this right here would be my only solution. This would not be a solution because it's not in the domain. So be careful to always check to make sure. So let's go ahead and look at example B. So I'm going to go ahead and erase this right here, but of course you want to keep that on your paper because you need that answer, but I need room to be able to write here. So for this next problem, we have the natural log of something equals 8 minus the natural log of something. So there's a couple different things you can do in order to solve this problem. We can do what we did before and make this 8. You can write it as a natural log. And we learned how to do that because what times 8 wouldn't change the problem, 8 times 1. So we can make that into the natural log of, or 8 times the natural log of e. Or if you wanted to, you can take this part of your equation add it to the other side. And remember, when you're adding to logarithmic equations, that means you multiply what's on the inside. So either way will work. I'm going to go ahead and just do the second way because it seems like it might be a little bit easier. I'll do the other way too, just to show you. So I'm going to add this equation to both sides. So when I do that, I would get notice that these are the same, so that you have two of them. So since we have two, you can write the natural log of, since two things being added, you're going to multiply it. So 2x plus 1 times 2x plus 1, which means you just have 2x plus 1 squared equals 8. So then in order to solve this, we're solving a natural logarithmic problem. So I'm going to have to write this in exponential form in order to solve. So base is e, so e to the 8th power equals 2x plus 1 squared, so that's 2x plus 1 times 2x plus 1. So if I want to continue to solve this, since I have two of them, instead of writing it like this, I'm going to leave it as the squared. You could write it all out if you wanted to. And I know that in order to solve for x, I can take the square root of both sides. But remember, when you're getting rid of even power, you need plus or minus your solution when you're solving. And so that's like taking both sides to the 1/2 power. So this would be e to the 8th all to the 1/2. So that gives me e to the 4th is equal to 2x plus 1. So then I could go ahead and continue to solve this. So if I continue to solve, I'm going to get e to the 4th minus 1 equals 2x. So divide both sides by 2. I get x is equal to e to the 4th minus 1 over 2. So I want to see this part for your answer, and then you can find the decimal form. So if I plug this into my calculator, e to the 4th minus 1 divided by 2, I get 26.7991. That would be one of my solutions. And remember, I said when you take away a even power, you need to do plus or minus your answer. But I know my answer is going to be negative, and I can't take the natural log of a negative number. And even if I come up here, I have to check to make sure my domain fits there. So here, x has to be greater than negative 1/2 in this case, and same thing for this one. So this is definitely bigger than negative 1/2. If I do this part up here, the negative answer or negative solution of that, I would get negative e to the 4th equals 2x plus 1. And then when I solve this, I would end up with a very large negative number that doesn't fit within my domain, so I can't do that answer. I only have the one solution. So what I want you guys to do then is see if you can just finish C, and we'll talk about that in class. Make sure you look through everything, and for this, notice that there's a log here and a natural log. This right here, that was my fault. That should say the log of x minus 1. So this is 1 minus the log. So make sure that you change that on your paper before you do the problem. Otherwise, you wouldn't be able to solve that. And of course, remember, if there's something that you were stuck on, you could go back and watch the video again after you take your notes.